All right, so for 5 and 6 quiz, number one, they want us to identify the population, sample population, parameter, and the sample statistic. So first of all, they want to know, they're giving us this, astronomers typically determine the distance to a galaxy, which they say is a huge collection of billions of stars, by measuring the distances to just a few stars within it and taking the mean of these distance measurements. So there's no way they can measure every single star in a galaxy because, like they're saying, there could be billions of stars. So that's why we pick our samples and stuff. Okay, so we take a sample of the overall population. So the overall population for this one would be, let's see, overall population would be B, all stars in the galaxy. So we're not talking about all galaxies, they're talking about a particular galaxy, okay? So then it says, well, what's the sample? Well, the sample is going to be the stars in the galaxy that we selected for the measurement. So let's see, down here, we would go with the stars that were selected, because remember, that's your sample. The population parameter. So overall, the population parameter would be the mean distance between all stars in the galaxy and the Earth. But then remember, sample statistic is going to be the mean again, but it's only going to be the mean distance between all the stars that were selected for the measurement and Earth. So it looks like I got B on everything. So your overall population was all stars in the galaxy. The sample was the stars that we selected for measurement. So that's what we was sort of wanting on that number one there. So I'm going to move that up a little bit. So number two says a sample statistic and margin of error are given. Find the confidence interval likely to gain the population parameter of interest and answer the question. So they're telling us 10 years ago, according to government records, 17% of the population of Elmwood had no health insurance. And that was 10 years ago, 17%. So now they're saying this year a poll revealed that 19.6% were without insurance. So we got 19.6% without insurance. But now they're telling us the margin of error is 2.2 percentage points. So that's going to be our margin of error. So let me move that up just a little bit more. So what we need to do, they want us to find a confidence interval for the true percentage without insurance this year. And then can we conclude that the percentage without insurance has increased from 10 years ago? So y'all, let's work this. So I'm going to start with the 19.6. So remember, your confidence interval will go from one number to another number. So to find where it starts at, you take the 19.6 and you subtract the 2.2 margin of error. So y'all, let's do that real quick. 19.6 minus 2.2 gives me 17.4. The two part takes the 19.6 and adds the margin of error. So you take whatever they're giving you for your statistic and you add and subtract that margin of error. So y'all, let's see what that gives me. what was it? 19.6 plus 2.2. That gives me 21.8. So first of all, you'll find the confidence interval over here. And it looks like there's only one that matches my answer, which was 17.4% to 21.8. So then it says, can we conclude that the percentage without insurance has increased from 10 years ago? Well, y'all, 10 years ago, it was 17%. So we're saying our smallest amount is 17.4%, all the way to a maximum amount that it could be, which was 21.8%. So since our lowest end is higher than the 17%, this would definitely be a yes. But I tell you, notice if you get the confidence interval right, you don't even have to know the yes or no part, right? Because there's only one that matched our numbers, okay? All right, so that'd be 1 and 2. All right, so then we hit number 3, find the mean of the data. So to find the mean, I'm going to add all 5 of these together and divide by 5. So remember, the mean is your average. All right, so let's go. I'm going to add them together. And when I get that answer, divide by 5. All right, y'all, so here we go. So 20 plus 18 plus 10 plus 20 plus 11, that's going to give me 79. And then I'm going to take that 79 and divide by the 5. That's going to give me 15.8. So let's see, that's over here. So there we go. Number D. All right, let me let one in real quick. Oh, where'd I put that? All righty, so the next one says, what's this one say? The students in Hugh Logan's math class took the Scholastic Aptitude Test. Their math scores are shown below. Find the mean score. So once again, we're going to add all these up. And then divide all them by what I have, 1, 2, 3, 4, 5, 6, 7, 8, 10 scores. All right, so let's add our numbers up. So 618, 542, 340, 352, 636, 360, 349, 594, 470, and 482. All those added together got me 4,443. And then I'm going to divide that by 10 since I had 10 scores. And I get 474.3. Now, if you do this all in one step on the calculator, make sure you put parentheses about your numerator, okay? All right, so let's see, 474.3. Oh, I must have punched in one of these numbers. Let me see what I punched in. 618. Let me punch these numbers again, y'all. 618, 642, 340, 352, 636, 360, 349, 594, 470, and 482. And then divide that by 10, like we said, 484.3. So I must have missed one of my numbers on there. So 484.3. So that would definitely be A. So, woo, you got to watch these numbers when you're punching them in here. All right, let's see what this one says. Find the range for the data below. So the range is going to equal the high number minus the low number. So my highest number over here, let's go, looks like 0.573. 0.573 minus my low number. So let's see, the smallest number here looks like the 0.111. So the 0.573 minus 0.111 gives me 0.462. So 0.462 would be my D. Okay, so the range just looks at what's the distance in between your largest number and your smallest number. All right, let's see what this one says. So I think there's like 8 of these. Yeah, so 7 and 8 will be the long ones. So this says the numbers listed below represent the amount of precipitation in inches last year in 6 different US cities. So they want us to compute the standard deviation and then round to 1 or more decimal places. So remember, by hand, you write all the X's, then you do the X minus the mean, then you do the X minus mean squared, add those together, and then you put them into that formula I gave you. But y'all, I'm definitely doing this one on this calculator. So here's what we're going to do. Clear that screen. So to enter this data in the calculator, you're going to hit the stat button and then click edit. So let me clear out these other columns. To clear them out, you highlight the top of the column where it says L2, hit clear. When you come back down, it clears that out. And I'm going to go to L1, go up to the L1, clear that, and bring my cursor back down. So I'm going to enter 1, 2, 3, 4.
Can you show your calculator?
Say again now?
Can you show that operation on your calculator as you're doing it?
Yeah, let me actually pull up my main screen here where I got my calculator app on it.
Yeah, if you don't mind, will you start from the beginning with that? Okay.
Mm-hmm. So let me go. So the first thing I do is hit that stat button. Is it showing you on my calculator now?
Yes.
Okay. Hit the stat button. And when we want to enter data, number 1, edit is highlighted. So you just hit enter on that. Now, let me show you. Let me act like I got some data in here real quick. So say you had data from a previous problem. To clear these rows out, you arrow up all the way till the L1 or the L2 is highlighted, and then hit clear. Now, once I arrow back down, those values disappear. Now, we're going to put in our data that it gave us. So it gave me 13.6. So I'm going to put in 13.6 and enter. It's going to give me 13.8. So I'll put in 13.8 and enter. 40.5. So 40.5, enter. 27.2. Enter. 12. And then my last one was 23 and enter. So hit enter on each one of those. So in my list, I now have a 13.6, 13.8, 40.5, 27.2, 12, and 23. So now we've got L1 set up with our data. So then I just hit the second mode button so I can quit that screen. So now let's see, what was we looking for? We're looking for the standard deviation. So to do the standard deviation, we hit second stat. So you hit stat to enter your numbers. When you edit it, you hit second stat to do everything else. So up here, we want to arrow right until it highlights the math column. Once the math column is highlighted, arrow down and find that standard deviation, which is number 7 for me. Once I got standard deviation highlighted, I hit enter. So now on your screen, it should say standard deviation. So now we got to get that list of numbers that we gave it. And we called that L1.
Can I ask you a question real quick? You said when you arrow right, it says math,
And
and
so
then
let me go. So let me.
and then you arrow down.
So watch this. I'm going to hit second stat, arrow right till math is highlighted,
Okay.
and then arrow down and get that standard deviation.
Okay. Thank you.
Then you hit enter for that. Now, we go back to second stat to actually get the list we made. So watch this. When you hit second stat, all the list you made will be where it says names is highlighted. Well, L1 is highlighted. That's where I put my data. So since that L1 is highlighted, all you do is hit enter. So now this is going to take the standard deviation of that list of data we gave it and called L1. So y'all, let's hit enter and hopefully we get one of these numbers. So they said round it one more decimal place. So since most of my decimals were rounded to one place, I'll round it 2. So that looks like it's going to be 11.02. So let me go to my other screen. So we ended up with 11.02, which is actually a choice for B there. Don't worry, you're going to get good practice on that standard deviation because every problem has me doing that. All right, y'all. So our next page. Let me get this squared away. So here comes a long problem. So they say auto transmission manufacturer receives ball bearings from 2 different suppliers. The ball bearings must have a specified diameter of 16.30 millimeters with a tolerance of plus or minus 0.1 millimeter. So recent shipments from the 2 suppliers had ball bearings with the following diameters. So supplier A, they give you their ball bearings. Supplier B, their ball bearings. So the first thing they want me to do is find the mean and standard deviation for each of these data sets. So I'm going to go to the calculator and I'm going to put these numbers in real quick and show you how I would do that, okay? So let's go to our new share. So I'm going to clear out all my old data. All righty, so to put in my data, I'm going to hit stat. I'm on edit, so I hit enter. Now I'm going to clear out L1 so I can use it again. So I'm going to arrow up to L1's highlighted, hit clear, and then when I come back down, it's cleared out. I'm going to put supplier A data in L1. I'm going to put supplier B data in L2. So for L1, we need 16.23. Enter. 16.26. Enter. 16.32. Enter. 16.33. Enter. 16.36. 16.42. And finally, 16.45. And enter. So I got all my L1 entered. So now I'm going to come over here to the second column for L2, and I'm putting supplier B's data. So supplier B had a 16.17. Enter. 16.22. 16.26. And this is how companies will check the vendors. You know, is that a reliable vendor? Are they getting them ball bearings to the size I need them and stuff, okay? What's next? 16.32. That's why these are such tight little decimal type problems. 16.38. 16.42. And then my last number, 16. Whoops, let me enter that. And then my last one was 16.45, enter. So remember, they want me to find the mean for these and the standard deviation. So I'm going to quit that screen, remember, by hitting second mode. So let's play with the first one. For supplier A, which I put in L1, we're going to find its mean and standard deviation. So we hit second stat, arrow over to math. And I'm going to start with the mean, which is number 3 on here. Yeah, I'll post this later on tonight. All right, so what was that mean? So hit mean and enter. So on your screen, it shows you the mean. Now let's go get L1 by hitting second stat. L1's highlighted, hit enter. So when we hit enter, we're going to get the mean for L1 list. So y'all, that looks like 16 point, let's see how far they want me to round these. Round to the nearest 100th. So I'm going to call that 16.34. So let's go get the standard deviation. That would be second stat, arrow over to math, arrow down to standard deviation number 7, hit enter. Get your L1 data, second stat, L1's highlighted, hit enter. Hit enter one more time, and my standard deviation, if I round to the nearest 100th, is going to be a 0.0. 7's got a 9 behind it, so I'm going to make that a 0.08. All right, same thing for supplier B. So let's get the mean for supplier B. We hit second stat, arrow over to math, arrow down to number 3 mean, hit enter. Now you can actually punch the numbers in, it'll pull it up. Like since mean was number 3, if you push 3 on the calculator, it'll pop that mean right up there. All right, remember, supplier B's data is in L2. So when you come to your names, arrow down to L2 and then hit enter. So the mean of L2 is going to be 16, rounding to the nearest 100th. That's going to be what, a 32. So 16.32. Now let's get its standard deviation. So second stat, go over to math, and then watch this, I hit number 7, it pulls it up that way also. And then second stat to get L2, see if I hit 2, it'll pull that up. So you can actually hit the numbers by them and it'll pull them up also. So let's see, let's hit enter and see, rounding to the nearest 100th, that's going to be a 0.1. That 0 has a 5, so I'm going to make it a 1. So I get 0.11. All right, y'all, so let's go back and see what they're wanting. So I punched in the data they gave us, 16.34 for the mean, 0.08 standard deviation, 16.32 for B's mean, and 0.11 for its standard deviation. So now they say, hey, draw a box plot for each data set. So let's pray these are in order. So let's see. So they did do good. They got our numbers in order here. Because remember, when you do box plots, you need 5 things. So the box plot, I need the median, the lower quartile, I need the upper quartile, And then I need the low and high values. Now the low and high values, since they're in order, we got that. What we got to find is all these other parts. So the median of A, let's see, we got 1, 2, 3, 4, 5, 6, 7 data units. So since that's odd, the median will be the exact middle number. So the median for A is going to be 16.33. So let me write that here. So median A is 16.33. To get the lower quartile, so the lower quartile, remember, is the median of the lower half of the data. So let's see, my lower half of the data would be these three numbers. So looks like, what's that, 16.26 is going to be the lower quartile. The upper quartile is the median of the upper half of the data. So its middle number is 16.42. So let's see, so we're getting down here. Now, I know my low and high value. The low value was 16.23. The high value was 16.45. So let me draw you the little box plot for that one. So remember, the rectangular box represents the lower quartile and the higher quartile. My low quartile was 16. Let's see, what did I get? 16.2, I'll go. My upper quartile was 16.4. Oh, I think I could round that actually to my lower quartile, 16.26. There we go. And then that was 16.42. So that's basically the ends of your box. Your median goes in the middle. Our median was 16.33. Now you draw your whiskers to the low and high value. So my low value, 16.23. My high value was 16.45. So y'all, let's look at this. This one don't even have whiskers, so it's gone. I'm trying to see. So notice my smallest whisker was 16.23, which they got it to the left of that, so it can't be that one. C, they don't even have the box. So let's check out D. Could be going to that. My quartile looks right, 16.26. My median looks around 16.33. My upper quartile, 16.42. So it's a little past 0.4. And then my right whisker, 16.45. So for supplier A, I would go with D. So just, and now watch this one. So we know this one cannot be A because it don't have a box, and D don't have the whiskers. So let's find our data for B. So the median for B will be the middle number on B's data, which is 16.32. Then we need to find our lower quartile and our upper quartile. So all this stuff is doing medians. So the lower quartile, you take the lower half of the data and find its median, which will be the middle number, 16.22. Upper quartile, you take the upper data and find its median, which will be 16.42. All right, let's see our low value and our high value. The low value was 16.17. High value was 16.45. All right, so we know it's not A and it's definitely not B. So let's see what we got going on here. So my low value, 16.17. So y'all, this one looks like it's left of 16.2, so that could be a 16.17. My low quartile, 16.22 looks good. 16.32 on the median looks good. Upper quartile 16.42, so it's past 0.4, so that looks good. And then finally, my high value 16.45, that looks good. So for that one, I would go with B. So notice on C, their low value was past the 16.2, so that's why I couldn't go with it, okay? Because my low value was at 16.17, which would have been over here on that line, okay? So y'all, then they say, so let me pull this down. What percentage of ball bearings from supplier A meet specifications? So their specifications were 16.30 plus or minus 0.1. So we'll subtract 0.1 and add 0.1 and see what we get. 16.30 minus 0.1 equals 16.20. 16.30 plus that 0.1 gives me 16.40. So to find a percentage, we find how many are within 1620 to 1640. Once we got that number, we divide by the total number. So we're looking for values between 16.20 and 1640. So that works, but the last two don't. So the first 5 are within the range. So you'll take that 5 and divide by the total number you had, which was 7. So let's see what we get here. So 5 divided, whoops, clear the screen. 5 divided by 7 gives me 0.714. Let me see how I wanted to round this one. So I'm just going to round it. To turn that into percent, you multiply by 100, remember, or move the decimal right. So we're just rounding it to the nearest percent. So that we don't want no decimals when they say round to the nearest integer. So that's just going to be 71%. All right, so now we got to find the next one. We want ball bearings in between 16.2 and 16.4. So that one don't work. So that one does, that one does, that one does, that one does. This one doesn't, and that one doesn't. They're too large. So I had 1, 2, 3, 4 good ones out of 7. So on that one, we'll do 4 divided by 7, multiply by 100 to turn it into a percent. So I get 57.1, which I'll call 57. So supplier A had a higher percentage than supplier B. See all this, not really what I'd call hard work. It's what I call tedious work. Sometimes you got a lot of steps on these. And let's find out number 8, our last one on this one.
Speaking to that, on Halloween, I did not have time to do anything. So I just answered whatever. I didn't realize how long that was going to take. It took so long.
Yeah, that's why I really love the calculator for some of these problems. Because, oh my God, y'all remember the other day, I think I had a video where we did basically one problem doing all that standard deviation and everything. Woo, that'll get you. All right, so let's see what they want here. The normal precipitation for August is listed for 20 different cities. Construct a box plot for the data set. So I don't really need a calculator for that. Unless I got an even number, then I'll have to use it just to average those middle ones out. So y'all, looks like, oh wow, so these are pretty much in order other than that 4.0 is in the wrong spot. 4.0 should be here, but everything else is in order. So let me write this out. 1.0, 1.5, 1.6, 2.0, 2.2, 2.4, 2.7, 3.4 twice, 3.5, 3.6 twice, 3.7 twice. Now I'll put my 4.0. So that's the only one that was out of order. 4.1, 4.2, 7.0. So we got 20 data points. So first of all, I'm going to get my median. And I'm going to write my values here. I need a median I need a lower quartile, upper quartile, my low value, and my high value. All right, so the median, since I got 20 of these, my median will be the average of the 10th and 11th spot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 are the two innermost spots. So add them together, 3.5 plus 3.6. Get that answer, divide by 2, and you get 3.55. So that's going to be my median. So now the lower quartile is the median of the lower half. So let's see, since I got 10 of them, the lower half will be the lower 10. So let's see, 1, 2, 3, 4, that'll be number 5 and 6 this time. So take 2.2, add to 2.4, divide by 2 to get the lower quartile. So 2.2 plus 2.4 divided by 2 gives us 2.3 for the lower quartile. Upper quartile, we'll take the upper half of this data. So the middle two numbers would be 1, 2, 3, 4, 5, 6, 7. There's 8 of them. Oh, hold on, where's my middle? Oh, I'm trying to look. Did I miss some numbers? Oh, I sure did, y'all. There should be a 3.9 here and another 4.2. Okay, so I missed them numbers. Ooh, that's where stats will get you. So I need the 5th and 6th one. So that's going to be 3, 7, and no, that's going to be my 3, 9, and 4.0 since I'm out of order. So add 3.9 and 4.0. Divide that by 2. I get 3.95. So that's where stats will get you if, woo, all these numbers with decimals, right? All right, low value was 1.0. High value was 7.0. So, woo, that 7 looks like an outlier. All right, so they didn't care about that. So let's draw the box. Lower quartile, 2.3. Upper quartile, 3.95. Median was sitting at about 3.55. Left whisker going to the low value of 1.0. Right whisker going to the value of 7.0. So y'all, let's see, A, B, C, or D. Ooh, look at that. A looks pretty much like it, right? 2.3, 3.55, 3.95, and 7. So I'm gonna go with A. So I don't know how they was getting all these 0.4s on that, but we don't care because those are all wrong, right? All righty, so that is your quiz for 5 and 6. All right, so what I'm going to do now is I'm going to show y'all a few problems they had for what's coming up next week. And you're going to like this a lot better than doing the standard deviation probably. So these were some things for 7A support. Now, y'all, these really ain't due this week. I just wanted to sort of use this extra time to go over a little bit of this. And I'll show you how to simplify these fractions on a calculator. So we're going to simplify fractions. So 3 over 15. So by hand, you would see what number you can divide out of both of these. So the only number you can divide 3 and 15 by would be 3. So divide the top by 3, the bottom by 3, and that'll reduce the fraction. But sometimes these numbers get really big, and it's hard to see what kind of factors to pull out of them. So let me show you the calculator how you would do these. And I'll show you 2 ways on it. So we're going to simplify 3/15. So let me clear this and clear that. So the first way is to go 3 divided by 15, hit enter. That's going to give you a decimal. So now we want it to look like a fraction and not a decimal. So then you hit the math button. And the first thing it says is that arrow pointing towards fraction means it's going to turn your answer into a fraction. So now see, it says answer turn into a fraction, hit enter, I get 1/5. So that's one way to reduce that into a 1/5. The other way, so let me clear that screen. The other way is to write it as a fraction. So to write it as a fraction, you hit the alpha button, which is green, and the y equals button up here. It pulls up this little box. N over D is what we want. That means numerator and denominator. So since that's highlighted, hit enter. So see, it brings it on the screen looking like a fraction. So on top I had what, a 3, arrow down, put in the 15. So y'all, if you want it to look like a fraction, use the alpha y equals for your fractions. Now, watch this. If you start with a fraction, it'll give you a fraction answer of 1/5. Oh, let me go back to that pad. So 3/15 reduced to 1/5. By hand, you would divide both these by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. So you basically remove any common factors. But y'all, here's a problem. Let me do one like my number 6. You got 1,925 divided by 3,920. It's hard to figure out what kind of numbers will go into this one. So that one is definitely one where you're going to want the calculator. So let's see, 1925 over 3920. So I like doing this. I like doing the alpha y equals way. ND's highlighted, so hit enter. On top, I had 1925. On the bottom, I had 3920. So y'all, that is a big number to try to simplify by hand. But on your calculator, you hit enter, and it gives me 55 over 112. Now you could have done the other way. You could have did 1925 divided by 3920, hit enter, it would have gave you a decimal. And then remember, turn the decimal into a fraction by hitting math and enter twice. All right, then it'll have you do a few rounding. So we've already done rounding, so I'm going to go into some of these other problems toward the end of this. So this one says, an experiment consists of drawing one card from a standard 52 card deck. What is the probability of drawing a 7? So we got 52 cards. So the possibility of drawing a 7. So what we got to figure out first, out of those 52 cards, how many 7s is there?
4.
So 4 7s. So there's 4 7s. So to find the probability, you take how many possible 7s you got, which will be 4, and divide by the total number of cards, which is 52. So that's why they were showing y'all how to reduce fractions, so that when you do probability, you can reduce those fractions. So if I got a 4 out of 52 chance, let's see, I'm going to do alpha y, enter. So on top I had 4, on bottom I had 52. You hit enter, you get 1 out of 13. So there's 4 suits of cards. You got hearts, diamonds, clubs, and spades. Each suit of cards has 13 going from the ace to the king. Okay. And then so out of each case, you got 1 out of a 13 chance of getting a 7. Okay. So that's all they're wanting there. So that'd be 1 out of 13. So that's what they're talking about. If you get a whole number right in, if you get a fraction, to simplify that down. So y'all, let's see what we do here. Suppose an urn contains 5 black marbles, 6 yellow marbles, and 9 white marbles. If one number is selected, determine the probability that it is yellow. So let's see, yellow equaled 6 marbles. Now we need the total amount of marbles. So we had 5 plus 6 is 11. 11 plus 9 is 20. So I got 20 total marbles. So the chances of drawing a 6, or I mean a yellow one, you had 6 chances out of 20. So reduce that down, and that'll give us our probability of drawing a yellow marble. So I'm going to go to alpha y equals, enter. So the top was 6, arrow down and put in your 20. So now when I hit enter, now basically, let's think about this. The only number you could divide out of both of these would be a 2. So watch this. 6 divided by 2 would give me a 3 on top. 20 divided by 2 would give me a 10 on the bottom. So if you were to draw 10 times, 3 out of them 10 times, you're going to get a yellow marble, okay? Or 6 out of 20, but those relate to the same thing, okay? All right, y'all, so let me find another one. All right, so I'm gonna wait on that. Let's see. So this one is another 7A support. There's 2 7A support ones coming through at you. So this one says, suppose that 4 6-sided dice are tossed. How many outcomes are possible? So you're tossing 4 dice. So let's see, the first dice, you got a possibility of 6. Then you multiply that by the second dice, which has a possibility of 6, times the third dice, which has a possibility of 6, and then times the fourth dice, because you got a possibility of 6, what do you call it, outcomes. So if I was going to find the total outcomes possible, I would do 6 times 6 times 6 times 6. So y'all, that would give you 1,296 possible outcomes from rolling 4 6-sided dice. So you can have 1 1 1 1, 1 1 1 2, 1 1 1 3, and so on. Okay. So that would be, let's see, that would be C, because you multiply all the outcomes. Okay. And this, each of the 4 dice had 6 possible outcomes. So look at this. License plates display 3 letters followed by 3 numbers. How many license plates can be manufactured for this state? So how many possible letters is there in the alphabet? I think that's what, 26 letters? And you're doing that 3 times. So that's going to be 26 times 26 times 26, right? A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So 26. Now, followed by 3 numbers. So remember, there are 10 numbers, 0 through 9. So that's going to be times 10 times 10. So we multiply all of them together, and that'll give me the total number of possible outcomes on these license plates.
Wait a minute. Wouldn't it be 9 instead of 10?
Oh, but remember, 1, 2, 3, 4, 5, 6, 7, 8, 9. But what about my 0?
Oh, 0.
Remember, 0 is a number on some of these license plates too.
Yeah. Okay.
All right, so let's see. Then that'd be what, times 10 times 10. So when you do that, you get, woo, what's that? 1 million. So 1,757,600. Now notice on that, that's just doing 3 numbers. Arkansas has, oh, hang on, let me see. I need one more number, don't I? So let me stop that. I need that other number. I had 3 letters followed by 3 numbers. So let's multiply that by another 10. All right, so that looks better. That looks like 17,576,000 combinations. So that's like Arkansas has a population of a little bit over 3 million, I think. So we got plenty of possible license combinations. So we could even have 2 or 3 cars each, and that would cover us, right? Because that's up to 17 million. Let's see.
I only have 2 numbers and 2 letters.
Do what now?
I only have two letters and 2 numbers.
2 letters and 2 numbers?
Mm-hmm.
Oh, that's cool. So that would be a lot less possibilities. So let's see, 2 numbers and 2 letters would be 26 times 26 times 10 times 10. So let's try that and see how many combinations they could do on that. So that's 67,000. Whoops, you can't see that. 67,600 possible license plates just doing 2 letters and 2 numbers. So yeah, that's probably why once they run out of license plates, once they went through the cycle, then they start different things. Like they used to put when I was younger, it always was the letters first, 3 letters and then the numbers. But if you notice now, they're doing numbers first and then the letters. So they're still getting up to 17 million combinations, but they're doing the numbers in reverse order. So woo, that's a lot of possibilities. All right, then you'll see some of these talking about rolling dice, spinners. That's about the marbles again down here. So here's the marbles, 3 white, 12. So doing that again, a 6-sided dice roll, find the probability of rolling an even number. Well, what, there's 3 even numbers, right? 2, 4, and 6. So that gives you 3 chances out of 6 total numbers. So you would reduce that 3 over 6 into, what is that, a 1/2. Oh, let's see. All right, so let me pull that back up. So this is still doing the probability stuff. This one says a fair coin is tossed 3 times in succession. So what they mean by fair is it has an equal chance of being a head or a tail. So it shows the outcomes that are possible. You can have head, 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 tail, head, tail, head, tail, head, head, heads, tails, 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 head, tails, 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 head, and then tail, tail, tail. So I got 1, 2, 3, 4, 5, 6, 8 possibilities. But we knew that because you had 2 times 2 times 2 possibilities, which gives you 8 of them, right? So now find the probability of getting exactly 2 heads. So that one has 3 heads. So I got 1 possibility there, 2 possibilities, 3 possibilities. So let's see, that's 1 head, 1 head, 1 head, and no heads. So 3 possibilities of getting 2 heads out of 1, 2, 3, 4, 5, 6, 7, 8 possibilities. And y'all look at that. If you do 3 divided by 8 and then turn that back into a fraction by hitting math enter, you still get 3 over 8. So 3 over 8 does not reduce. So that would be the final answer there. And then this one will take us more time, but we'll do that one next week for sure. But all you're going to do is figure out the combinations. You're having 4 kids. So you can have 4 boys, 3 boys, a girl, 2 boys, 2 girls, 1 boy. Okay. So if you're having 4 children, each time it could be a boy or girl. So you're going to have 8 outcomes for that one, just like you did up here. Okay. So, oh, hold on. I had, yeah. So 2 times 2 times 2, that'd be 16. My bad. So when you make out your chart, you'll have 16 possibilities. So just keep writing down all the possibilities till you get all 16 of them. Then see how many of them have 1 girl and 3 boys. So I'll let y'all sort of play with that. And then if y'all need me to fix y'all, I can fix that on Tuesday when we come back. So that's basically what we got coming up. And that kind of stuff is a lot nicer than doing all that standard deviation, okay? Not as hard math-wise. Most of it just involves reducing a bunch of fractions down and then figuring out all those outcomes, okay? All right, so on your projects, at this point, hopefully you've got you a survey going and then start collecting your data, okay? So pick out one of them questions I sent on that project, get it on some kind of social media or call them or ask them in person, but try to get anywhere from 20 to 25 responses, because next week we're going to start making our frequency tables. All righty, y'all. So I'm going to stop our recording.